All right, so this is Essentials for College Math, lesson 1.4 on the properties of real numbers. So I'll go ahead and get started, okay? So with these real numbers that we're going to be dealing with, we have certain properties that we can take to indeed be true, okay? These are things that with these numbers, we can always assume that these statements will always be true no matter what the case is. So first up, we have, make sure my pen works, the commutative property. So the commutative property states that when adding or multiplying, if we change the order, that we're going to get the same result. Okay, so this only applies to adding or multiplying. Okay, if we try to switch the order in subtraction, we might accidentally get the wrong sign or just a wrong value altogether. The same thing with division. If we try to switch up division, 2/3 would not be the same as 3/2. Okay, we can type that in our calculator, we can verify that. But with these other ones, if we're adding or multiplying, it doesn't really matter. Okay, so for example, using the commutative property, rewrite the following, okay? So 8 times 5, if I was to rewrite this statement using commutative property, basically rewriting it so that it's still equivalent, it just looks a little bit different, then I would just switch the order so that 8 times 5 would be equal to 5 times 8, okay? And so we can check and make sure that these are both equal statements if we just type them both in the calculator. 8 times 5 is just 40, just like 5 times 8 is just 40. Okay, so it works with multiplication. It also works with addition. Okay, so 26 plus 34 would be the same thing as 34 plus 26. And if I was to add both of those together, type them in my calculator, I would get 60 for both. So that's just a commutative property at work. Okay, last example, 6 times 17, just reverse the order using commutative property, will be equal to 17 times 6. And if I multiply those together, I'm going to get 102 for both. So that's the commutative property. For addition and multiplication, switch the order and it doesn't change anything. Next up, we have the associative property. The associative property. All right, so the associative property, like the commutative property, only applies when we're dealing with addition and multiplication. Again, subtraction and division gets a little bit hairy, so we're not going to deal with those. But for addition and multiplication, if I have certain numbers grouped together, like in this case of a plus b is in parentheses, and then plus c is outside, that's going to be the same thing if I just change up the parentheses. Not necessarily change up the order, which we just learned we could do a commutative property. But if I just change up the parentheses, write it the same order, and just group different numbers, in this case b and c, then that's not going to change the value for me. Say with multiplication, a times b times c would be equal to a times b times c. Okay, so let's put a couple of these at work. Okay, so if I was to rewrite this statement differently, 9 plus 5 plus 6, then I would write the numbers in the same order, and then the 9 and the 5 were grouped first, so this time I'm just going to group some different numbers. The 9 plus 5 plus 6. Now, if you want to check and make sure this works, we need to use the order of operations to check it. Okay, now order of operations states that I need to start with my groups first, okay? So on the left-hand side, I would start with 9 plus 5, and that would be 14 plus 6, because I didn't use plus 6 yet, so I'm going to rewrite it exactly as is equal to, well, this time I'm going to start with group again, but the group looks a little bit different. So I'm going to bring down the 9 plus, and then 5 plus 6 is just 11. Okay, so these steps look a little bit different, but once we add them together, 14 plus 6 will give me 20, 9 plus 11 will give me 20. We'll get the same answer. Okay, so associative property does not change the value of expressions. Okay, example 2. 2 times 3 times 6, we can rewrite it as parentheses, 2 times 3 times 6. And then if we went through and just verified it, we would get 2 times 3 times 6 in the group, that would be 18, is equal to 2 times 3, which is 6 times 6. 2 times 18 will give me 36. 6 times 6 will give me 36. Okay, last example. 5 plus 12 plus 19. 5 plus 12 in parentheses plus 19. This would give me 5 plus 31. This would give me 17 plus 19. And I would once again get 36 for both. So associative property, if we have addition or multiplication all across the board and we just switch up the groups, not going to change anything. Now, we cannot mix up addition and multiplication. Okay, so for example, we couldn't do something like 3 plus 2 times 5 is equal to 3 plus 2 times 5. Okay, So let's see if we tried this. So if we tried this, okay, so we wrote them in the same order. We didn't change up the signs, we just changed up the group. So if I did this, then this would be 3 plus, get the group knocked out, 10 is equal to 5, 3 plus 2, 5 times 5. And so this would give me 13 and 25. So as we can see, 13 and 25 are not equal to each other. So the associative property can work with addition only if every single sign in the expression is addition. Okay? If we try to mix it up, have a little bit of addition and a little bit of multiplication, it doesn't work out for us. So it has to be across the board addition or across the board multiplication. All right, next up we have the distributive property. Move my camera real quick. All right, so next up we have the distributive property. So the distributive property comes into play if I have a number that is outside a group parentheses and I'm trying to get that number inside instead. Okay, so in the case of a times b plus c or a times b minus c. Okay, so with this one we could technically apply distribution to multiplication. Then it would just basically be just us multiplying three numbers together, kind of the same deal with division. So we really only think of distribution in terms of addition and subtraction. So if you have a number that is outside of parentheses and inside the parentheses you have addition or subtraction, then there's two ways you could potentially solve it. And as we keep going on through this course, you may find benefits to either knocking out the group first, or there may be times when we can't knock out the group because there might be a variable involved, in which case you need to distribute that little thing. Okay, so let's look at a few examples of this. Okay, so example 1, we've got 2 times 3 plus 2. Now again, in our brains immediately, we can probably quickly just say, okay, 3 plus 2, that's 5, and then 2 times 5 would give me 10. Okay, that'd be through the order of operations. So we're going to verify that that also works through distribution. Okay, so I'm going to draw these little curves, okay, just basically signifying I'm going to multiply 2 to this and 2 to this. So when I rewrite this, this will be 2 times 3, and I'm going to put it in parentheses. Remember, that's going to signify a multiplication, plus 2 times 2. So 2 times 3 will give me 6. 2 times 2 will give me 4. 6 plus 4 will give me 10. Okay, so again, in our brains, we probably immediately went 3 plus 2 is 5. 5 times 2 is 10. And that would be correct using order of operations. I just went through and verified that we could also use distributive property. Okay, likewise, we can do the same thing here. So we would get 15 times 12 minus 15 times 9. 15 times 12 would give me 180. 15 times 9 would give me 135. And then 180 minus 35 would indeed give me 45. Okay, example 3. So this time, they threw a variable into the mix. Okay, so we're going to now distribute the variable. Okay, so this will be x times 8 minus x times 5. Okay, now this notation might be a little bit weird for us, okay, because normally we're used to seeing the 8 or the 5 in front of the x, but this notation is still correct, okay? It's not something that's normally widely used, but it is still correct notation. So x times 8 would just be 8x. We're going to rewrite that way because that's the way we prefer, minus x times 5, which is 5x, and then 8x minus 5x. So whenever we're subtracting things that have a variable, we first have to check and make sure that the variable is the same, so they're both x's, and they're both x's to the first power. So if they are both x's to the first power, or they're just both the same variable and the same power variable, then we can subtract the coefficients in front. So 8x minus 5x will give me 3x. Okay, one last example. We have y times 15 plus 23. So this will be y times 15 plus y times 23. Okay, multiply those together, kind of reverse the order. 15y plus 23y. Add those together, and we will get 38y. Okay, so distributive property, you have a number outside of a parentheses, you want to multiply it into a group that has addition and or subtraction, then you can do that. Okay, all right, let's look at these last two. All right, so last up we have the identity property. So we're going to think of the identity property in two different variations. Again, one is with addition and one will be with multiplication. So the identity property of addition is going to state that for any real number a plus 0 equals a, and 0 plus a equals 0. So the whole idea of this is that we needed to think of a number that could we add any one number to any other number and it still be the same? Basically, is there something that we could add that it wouldn't really change anything? And that number that we discovered is 0. So we call 0 the additive identity. The additive identity, because it is the only number that you can add to a real number so that the value will not change. Okay, and that kind of makes sense even in our real world. Okay, if I have $5 and you give me $0, I still have $5. You giving me nothing did not change the fact that I still have $5. Okay, so, and if you start out with nothing and then I give you $5, then you're not going to have any more than what I just gave you. So you're still just going to have just that $5. So adding 0 to any real number will not change the value of it. All right. And then lastly, we have the other identity property, and this is the identity property of multiplication. So kind of a similar idea. We needed to figure out a number that we could multiply it by anything and then not change the value of that anything. Okay, and the number we discovered was 1. So because of that, 1 is known as the multiplicative identity. Okay, the multiplicative identity, because it is the only number that you can add to any real number so that the value will not change. Okay, so anything times 1 will still just be that anything.